Hi Sriharika, good evening.
Hi Nitish, good evening. How are you?
Yeah, I'm good. What about you?
Yeah, I'm good. Thank you.
Okay, let's start our project presentation. I'm sharing my
Yeah, sure.
screen. Yeah, let me slide. Yeah,
Yeah. Good evening, Professor. My name is Sriharika and my teammate is Nitish Chapala. Today we are discussing about our project is face mask detection. The face mask detections refers to like detecting whether a person is wearing a mask or not. And the next one is these are the contents that are going through our project like abstract introductions, motivation, and problem statements, existing systems and drawbacks, and the proposed systems and advantages like system requirements and algorithms and data sets, and the approach and CNN, cascade and workflow, and epo cycle, and the graphs, and the results and implementation, conclusion, and the last one is the future work. And then now moving on to the abstract. uh, Here we can talk about the face mask detection that is reliable and efficient is now required because of the COVID-19 pandemic in the public locations, including airports, hospitals, and schools. And using the use of Python programming, the artificial intelligence, like we present a plan in this project to handle the problem AI. The convolutional neural networks, the mask classification models, and hard cascade classifiers, and the deep learning based face identification techniques are just two of the computer visions and the deep learning techniques that systems will be used. And the moving on to the introductions, like we are first talking about the what is the AI, like nothing but the simulations of the human intelligence process by machines, like especially computer systems. And the specific applications of AI includes expert systems and the natural language processing, speech and recognitions and mission visions. And face mask detections like using AI involves the use of computer vision techniques and to identify the individuals who are not wearing face masks in public places. And the aim of this technology to promote the compliance with public and health guidance on the use of face masking during the COVID-19 pandemic. And the moving on, yeah, these are the difference between the artificial intelligence, machine learning, and the deep learning. The first one is the artificial intelligence is ability to mission to imitate the human intelligence, and the machine learning is the subpart of the AI. It means algorithms to incorporate intelligence into the like mission by automatically and learning from the data. And the deep learning is subpart of the machine learning. Like that is an algorithm that mimics the human brain to incorporate intelligence into the mission. Like moving on to the motivation, like we got some motivations from the coronavirus. And because the coronavirus spread quickly, the World Health Organizations advises people to keep a safe distance from others and wear the face masks. And to advance the ongoing battle against the hazardous diseases, like we are push learn new things by sharing the data about the people who don't wear face masks and applying the deep learning techniques. And the like moving on to the problem statements, like the image which shows a public area has some people are wearing masks and some persons are not masked. They want to create a system like that can decide whether not wearing a mask or without mask. We can observe like if there is a no mask, a red box should be around the face, and if there is a one, a green box must be around the face. And moving on to the existing system, like these are the system face mask detections involves manual checking and monitoring individuals in crowded public places, like such as airports, schools, shopping malls, like etc. Like this system is highly inefficient and time consuming as it requires a large workforce for constantly monitor individual and ensure compliance with the mask wearing protocols. And the moreover, it can be prone to the human errors, leading the high risk of spreading infectious diseases. And then moving on to the drawbacks with existing system, we have these are the drawbacks like highly inefficient and time consuming, like means that it takes a lot of time and effort to get something done. Like in the case of face mask detection, this means that the current way of checking if someone is wearing a mask or not. And moving on to the second one is requires a large workflows to constantly monitor individuals. Like it means the system cannot function autonomously, like must rely on the human operators and to monitor and enforce the mask wearing policies. And it should be like costly and time consuming. And moving on to the prone to human errors, leading to a higher risk of like spreading infectious diseases. Um, that one is system fails to detect individuals who are not wearing the masks. And the next one is the proposed systems. These systems can learn from the data sets. Here we can observe the picture. Some of the peoples are wearing the mask and some of the peoples are not wearing the masks. And the deep learning model trained to the largest data set images and automatically detect whether the individual wearing a mask or not. And the system utilizes computer vision to identify the faces and to determine the presence of the absence of the mask. And the system can deploy the various public places like to ensure the compliance of the mask wearing protocols and thereby reducing the risk of spreading infectious. And moving on to the next part, advantages of proposed system. Here these are the advantages we can see, and highly efficient and automated systems. And the second one is the reduces the need for a large workforces to monitor individuals. And the third one is minimize the risk of human error in detecting mask wearing the complaints. And the fourth one is helps in the prevention of the spread of infectious diseases. And next part, the moving on to the which are we are going to use the software requirements and hardware requirements. Like software requirements, we are using Windows 7 or above, like version operating systems and Python 3 version, and the OpenCV, TensorFlow, Keras, NumPy, and Visual Studio Code. Moving on to the hardware, we are using laptop Intel i5 core and RAM 8 GB or more, and GPU, and the storage at least 10 GB for free disk space for storing the dataset, model checkpoints, and other related files. Let us talk about the algorithms. We have three algorithms. We are using the conventional neural network and image data generator and hard cascade classifier. And the conventional neural network is a type of deep learning algorithm. It is commonly used for image classification tasks, like to distinguish between the image of people wearing a mask or without mask. And a CNN can be trained off a largest data set of images, like both masked and unmasked faces. Moving on to the image data generator, in a Keras of flexible tool, it allows to apply this transmission of the images, like in the training data set in real time during training, and can be used to improve the accuracy and efficiency of your like deep learning models. Moving on to the hard cascade classifier, like it is an object detection algorithms, and we are used to identify the faces in image on a real time video. Like it is an effective way for the object detection. And in this approach, a lot of positive and negative images are we like used to train the classifier. In this model, pre-trained with the frontal features is developed, and also we use this experimental and detect the faces in real time. And moving on to the data set, like using the algorithms which we are created the data sets, and we are training our model without mask, and we are using with mask and without mask, we can find out. And moving on to the approach, here we are building deep learning model and running hard cascade, like to train the hard cascade classifier. And the algorithm first selects a set of positive and negative images, like mm, the positive contains examples of the object of interest, and while the negative images do not. Here we can talk about the how CNN works in the face mask detections, like the flow can works, and using the CNN face mask detection can be used like automatically and classify images as containing a person wearing a mask or not wearing a mask with high accuracy. We are we are using the objected identification. And the next one is hard cascade future. This one is we are using the whether the object is identified or not. Like we can use three we are identifying the three ways like edge features and line features and center surrounded features. Like the first one is the head features, means it is used to detect edges, like is an image which are important for identifying object or boundaries. Like the head features are typically horizontal or vertical rectangles that cover both light and dark regions. And moving on to the line features are like similar to the head features, but are oriented diagonally. They are used to like detected like adjacent images, which can be important for identifying curved objects. And moving on to the center surrounded features, these features consist of a rectangle surrounded by several smaller rectangles, and they are used to like detect the difference in textures and in uh, intensity between the center and surrounded regions on images. And the next part will be continue my frame.
Yeah, thank you, Harka. Thank you for going through. Yeah. Hi guys. Yeah, now I am going to explain our flow of our model. So at first, our model is going to perform data pre-processing. As we all know, data pre-processing nothing but the data is in the correct format which is suitable for the analysis and to minimize the impact of the errors inconsistent in the data. And in data processing, we have different types like data cleaning, data transformation, data integration, and data reduction. These are all we are going to do in our model. And after pre-processing the data, we are doing the data augmentation. Data augmentation is a technique used in machine learning and deep learning to increase the amount of training data by creating a new data points through transformation of the original data. So the idea behind the data augmentation is nothing but increasing the diversity of the training data. The model will be more robust and better able to generalize the new and unseen data like what we expect in our future. Yeah. And after the data augmentation, we are going to split our data set into a train model and a test model. 80% is divided into train model and 20% for the testing purpose, which is nothing but a validation. After splitting our data, we are putting our model going through a CNN mode classifier and Haar cascade classifier. As we all know, both CNN and Haar cascade are the effective approaches for the face mask detection. And choice between the two may depend upon the factors such as the size of dataset, the complexity of the task, and the availability of the pre-trained models. Right now, we are going to use both the models for as CNN for the face detection and Haar cascade for the mask detection. So after it gone through the classifier, our image like our video is going to detect our face like we are wearing a mask or not. If we are wearing a mask, then our image is like green color rectangle box which is green which is nothing but we are wearing a mask. And if we are not wearing a mask, then it's a red color rectangle which is nothing but we are not wearing any mask. So this is how our model works. So I'm going to show you live how it works in the coming next slides. So as you can see, this is what accuracy we got during our training phase. So as you can see, this is training loss, this is training accuracy, this is variable loss, and this is variable accuracy. As we go for we have done our training model for up to 20 cycles. As you can see, our training loss is goes on decreasing as we increase our cycles on training model, as accuracy also goes on decreasing as we increase our cycles. So we will get a best output if we train our model more than once, like more than 20 times. So this is how our model works. And you can see this is the graph we got like when we train our model using a data set. So as you can see here, this blue line nothing but a training loss, and this orange line is nothing but a validation loss. As you can see at the start, training loss is very low and validation loss is high. When it comes to here, training accuracy and validation accuracy, you can see training accuracy more than the validation accuracy. This is the model works. So this is the result which we are going to expect in our project. So as you can see in the single frame, we are able to detect the the person who is wearing the mask and person who is not wearing the mask. As you can see, the person who is wearing the mask is shown in the green color rectangular box by showing he is wearing a mask. And a person who is not wearing the mask, it is shown in a red color box, which is not he is not wearing the mask. This is how our model works. So here I placed the images, various images to show how our model works, how it is able to detect the images, how its total functionality. Right now, at first model, as you can see, it's taken during without any model. It's a simple picture which we are going to use at first. And after that, after we run our model, our camera is popped out. As you can see at that time, I'm not wearing any mask. So our model shows in a red color box, which as indicating no mask. And after that, I have placed an object in between our camera and our body. So as you can see, if you place any object, our model is able to detect it and it can directly say it is not a mask. So it can say the person is not wearing any mask. At last, I wear a mask to check our model, right? We have to check. So as you can see, at last, when I wear a mask, you can see it's a green color rectangle, which is indicating us a person is wearing a mask. So this photo is taken at the time when we are wearing a mask. Okay. And let's see how our model works with all the code and with all those things. So this is our code. Let me run the code as it right now I'm running it for 15 cycles. It will take time. While it is running, I am going to explain the code and what are the various steps involved in this code. It's going for only 10 models. So in the meanwhile, I am going to turn off my video because the system cannot, as Zoom is using my video, our model cannot use at the time. So I'm closing my video. Yeah. Now I'm going to explain our code. At first, we are importing all the variables and libraries. At first, we are importing NumPy library, which is used for mathematical operations on arrays or matrices. And at second, we are using importing Keras and TensorFlow, which are libraries used to build and train the deep learning models. And next, we are using Keras backend, which is nothing but a provides low level operation that the deep learning model will use, such as tensor manipulation optimization algorithms. And next we are also importing so many layers like which we are going to use in our face detection model, like convolution 2D, max pooling 2D layers user for convolution and pooling operations on the input images. And next we are importing a sequential model which we are going to use in our project, as it is the linear stack of layers for the face detection model. The load model function will be used to load the pre-trained model for the further use. And next we have imported our Adam, which is a popular optimization algorithm used for training deep learning models. And next we are using Tensor Keras pre-processing image, which is used to pre-process input images for the face mask detection. And next we are use CV2 library, which is a computer vision library that will access the camera and perform real-time face detection, which is very important in our case. And next we have important our date time, as at the time when we are detecting our face marks, at the same time it's going to detect our time at the neat. Mm. And next we are building our sequential model. As you can see, we are initializing sequential model and filtering our model by using convolutional 2D and max pooling for more than 3 times to get a best output. We have filtered up to 3 times right now. In this, we are composed of 3 convolutional 2D layers and 3 max pooling layers and 2 dense layers, which is nothing but 101 neutrons, and train data is saved as HY file in this model. At last, you can see we have used rectified linear unit and sigmoid, which is nothing but a non-linear activation models used in our project. And we also imported image data generator to process the image data. And next, after processing the image, we are creating a instance of image data generator class to apply data augmentation techniques to our training model. After training our model, we are creating another instance to rescale the pixel values of the test data. After creating instance for a text data, we are generating trained models and its labels by reading the images from the directory which we have here. As you can see, we have data set like with mask, without mask, all those things. These are all with masks. And these are the data set which we are having. We have so many images right now here. So after this, it's also generating a test data and its labels by reading the images from test data. So after generating these models, we are fitting the model on a trained data and validating it on test data and saving it onto my model underscore saved. And after we saved, we will get a H5 file. So here, after that, we saved, we are plotting a graph between the training loss, validation loss, and training accuracy and validation accuracy, which we are going to see in the next step. So right now I'm going to show implementing live detection of face marks. By using the model which we saved, we are loading the saved model and initializing the video capture object. And we are loading the HAR cascade classifier for the face detection. So we use HAR cascade classifier, and if we'll get the output and probability between 0 to 1. If we get the probability between, if the score is above 0.5, it means that no one is wearing mask. So at that time we can get a red color rectangle box which indicates no mask. And if the score is below 0.5, it says that we are wearing a mask, and it is shown in a green color rectangular box, so indicating that person is wearing the mask. So this is how our, we have loaded the faced image and resized to require input for the model. And in this line we can see we are drawing a rectangle around the face and labeling with the prediction result. And this color is nothing but a red color 00, and 0 to 25 0 is nothing but a green color. So at last we are putting a date stamp at the right below corner of our image, as you can see in the next few steps. So this is how our code total works. So the script continues to capture and display the video feed till we press the Q. This is how, and I think our model train is over. I think in few minutes we can see our output. Let's wait. Yeah, you can see here we got a graph indicating train loss, validation loss, training accuracy, and validation accuracy. As you can see, validation loss is greater and training loss is lower at the last on 20 cycles, 10 cycles. As here you can see, the accuracy is more than the validation accuracy. Now we are able to see how our model works. As you can see, very accurately it is working. As I'm not wearing any mask, it shows I'm not wearing any mask. Let me put a mask right now. As you can see now, our model works very perfectly. It shows us we are wearing mask. So this is how our model works. So, and we also implemented for image detection also. Let me run the code. This is our code for image detection. Here we have given an image, this image, which is wearing a mask. So I'm going to run this code. Let me run this code. We are giving input our code. As you can see, the green color rectangle bar which shows the person is wearing a mask. In the same way, we will get a person who is not wearing a mask. This is how our image detection works. And we also have an accuracy. It show how our test model accuracy, how much accurate we are. Let me show it. You can see we have for our test model, we have got accuracy of 97%, which is very accurate. And I also established a README model, and we have also implemented our code in GitHub. We have uploaded our code in GitHub. You can access it from anywhere. As you can see, I have also given README file, which is very easy if anyone is accessing our project. As you can see how our project works with mask green color rectangle box and no marks red color rectangle box. And I also given instructions how we can use this GitHub. And we have also have documentation which we have prepared for our project. In this, we have included all the steps which we achieved in our model by explaining each and every step and by explaining all the what are requirements and what are the software specifications and what are the tools we are used and what are the literature surveys. And this is a system architecture how we have developed our model and what are the libraries we have installed for each and every step and data set. All the algorithms and can see here Hark as a classifier features. This is how we have developed our documentation report. And in this, we have also given a graph which we got earlier in our output. And this is how we will get, as you can see in results, this is how we will get results as you can have seen earlier. Yeah. So coming to conclusion, face mask detection system is an automated solution. Let me on my cam. Yeah. Face mask detection system is an automated solution to the face mask detection problem. For a face mask detection problem, we have face mask detection system. The system leverages deep learning techniques and computerized computer vision algorithms to identify the presence and absence of face masks. So, our system can be integrated with CCTV cameras in all the public spaces like hospitals, like railway stations, and many more. So, we can implement our model by using CCTV cameras. Coming to our future work, we have to enhance the system by improving the accuracy of our face detection model using the transfer learning to fine tune the mobile net V2 model and integration system with a real-time monitoring system. The system can also be extended to detect the other safety equipments like helmets, safety glasses, and industrial settings. So, guys, this is our project, and you can access our code in our GitLab, which I have provided you. You can access all of my code, and thank you. Yeah, thanks, Harika, for explaining all the things. Yeah, thank you.